In this chapter, we will be studying systems of linear equations. In this lesson, we will be solving systems by using elimination.
Now we're going to take a look at solving systems by another algebraic method, by elimination, or some people call it the addition-subtraction method. What we're going to do here is it's actually an interesting application of mathematics. What we're going to do is we're going to, instead of adding together terms, we're going to actually add together functions. We're going to add together linear functions, and you're going to see how we can very quickly take a system of two equations with two unknowns and reduce it to a single equation with one unknown that we can therefore solve real quick. Okay? So what we're going to do here, and we call it the elimination method because what we're going to do is by adding and subtracting two equations together, or sorry, I should say adding or subtracting, we're going to eliminate one of the variables. So what we do is we line up all the variables. Now usually we do this in standard form. Now it does not have to be standard form. It's just that usually we do this in standard form. Okay? Now, first of all, what we're going to do here is you're going to look to see if there are any coefficients. Sorry, you're going to look at a single variable like x or y in the two equations. You're going to check to see if they have the same numerical coefficient. If they do, that's great, because then that means that by adding and subtracting the two equations, you can immediately eliminate that particular variable. Now, if the two terms here have opposite signs, you simply have to add them together. But if they both have the same signs, if they're both positive or both negative, then you're going to have to subtract the two equations from each other to get rid of that variable. If a mistake is going to pop up, it's going to pop up right here. Okay, I'll tell you right now, we already know that the negative signs are going to cause people problems. We are already very familiar with that. So I'm just letting you know right now, if you see negative signs in there in front of the coefficients and you're going to get rid of that variable, be extra careful, okay, that you do that correctly. When you subtract a negative, it's the same as adding that positive value. Now, on the other hand, if none of the coefficients are the same, then what we're going to do here is we're going to alter the system, or at least the way it looks, by simply multiplying through by values that will make the coefficients of either the variable, either the x or the y, the same. Okay? Typically what you want to do here is you want to choose the least common multiple between the two coefficients, because that's usually the easiest to work with here. But just make sure that when you multiply it through, you're multiplying all of the numbers in both of those equations through. You're either going to make it so that you've got a positive term and a negative term, so that when you add them together they disappear, and make that easy, or you keep them the same and then just make sure that you're subtracting appropriately. Now that really doesn't give you a sense of exactly how this is going to work. I understand that. Describing the procedure here is not nearly as effective as demonstrating it. Okay, but this is the idea. Our goal here is to get rid of a variable, and we do that by making sure that the coefficients are the same. If they're not already the same, okay, then you're going to multiply the two equations through by whatever you need to make those coefficients the same. And then you're either going to add or subtract the two equations. But let's have a look at some examples, and hopefully you'll get a sense of how this works. It turns out most people actually, in my experience, most people prefer this method as an algebraic method of solving systems. All right, so here we go. We're going to solve this system by elimination here. So here's equation 1, here's equation 2. Now notice right away that the coefficients of y in both of these equations are 1. Okay? Now what I'm going to do here is I'm going to draw a line underneath here, and I'm going to take equation 1 and I'm going to subtract equation 2 from it. So now you do this term by term. You're still doing combining like terms, but we're combining the terms of two separate equations. So 2x minus x is x. Y minus y is 0, and that's the elimination part of this. Now be careful. Negative 7 minus negative 5 is actually negative 7 plus 5, so it's going to be negative 2. So immediately I get out of this x is equal to negative 2. Now, with the substitution method, you have a ready-made tool for finding the other coordinate that you didn't use. Here you don't. It's a little quicker to find the answer for one of them, but to find the other one, you got to plug that back in. Now, I'm pretty lazy, so I'm going to take that point and I'm going to substitute that back into equation 2 here. So x is negative 2, so I'm going to make x equal to negative 2 plus y is equal to negative 5. And I'll bring the 2 over. I'll add 2 to both sides, so y is going to equal, well, negative 2, 5 plus 2 is negative 3. So the point that I think is the answer here is the point negative 2, negative 3. Now I used equation 2 to get the missing coordinate, to get my final coordinate. So I'm just going to verify this in equation 1. So 2 times negative 2 plus y, negative 3, is that equal to negative 7? So is it true that negative 4 plus negative 3 is equal to negative 7? Yes, that's true. And so my final answer here is the point negative 2, negative 3. All right, this next question is sort of similar to the previous one in that the coefficients here of the y coordinates, again, or the y variables, are the same, except they have opposite signs now. So here's equation 1, here's equation 2. I'm going to draw a line under it. Now, because these are different signs, okay, they're already set up. All I really need to do is take equation 1 and add equation 2 to it. Okay, because when I add those two together, they're going to cancel each other out here. So but I got to do this to every term here. So x plus 3x will be 4x. Negative 2y plus 2y is 0. And 7 plus 5 is 12. And then I'll simply solve that little equation that I've got, now that I've got one equation with just the one unknown, and I'll get that x is equal to 3. Now, again, I need to do a little bit of work to find the remaining coordinate here, but I'll maybe plug this into equation 1, because I think equation 1 is maybe a little easier to work with. So I'll plug that up there. So I got my answer, x is equal to 3. That should work in either one of these equations, but I'm going to choose equation 1. So 3 minus 2y is equal to 7. And I'll subtract the 3 from both sides, so negative 2y is equal to 4 when you subtract it, and so y is equal to negative 2 when I divide by negative 2. So the point that I think is the answer here, assuming I didn't make a mistake here, is the point 3, negative 2. I used equation 1 to get my final coordinate, so I'm going to use equation 2 to check it. We're going to verify in 2. So 3 times 3 plus 2 times negative 2. Does that equal 5? Okay, well 3 times 3 is 9. 2 times negative 2 is negative 4. Is 9 minus 4 5? Yes. So that point right there, 3, negative 2, is the solution we're looking for. All right, here's our next example here. Notice that neither of the two variables here in the two equations have the same coefficient. Okay, so we're going to have to do a little bit of work here. Now, it turns out we simply have to make a choice. It's either going to be the x coordinate or the y coordinate that we want to eliminate. In this particular case, it doesn't really matter. Now, I'm going to choose the x coordinate because I want you to be aware of the fact that you can do this. In the last two questions, we eliminated the y variable from the beginning, but that doesn't necessarily have to be the way that works. So I'm going to draw a line under here. Now, to get rid of the x coordinates, what I'm going to do is I'm going to take equation 1 and I'm going to subtract. Now, in order to make those two numbers the same, I'm going to multiply 3 times equation 2. So this is what I'm about to do here. So 3x minus 3 times x. Oh, the x's disappear. Okay. Negative 1 minus 3 times 2. Okay, that's going to be negative 1 minus 6. Negative 1 minus 6. Okay, it's going to be negative 7. Y. And then 11 minus 3 times 6. Well, 3 times 6 is 18. So it's 11 minus 18. That's going to be negative 7 again. And when I solve for y, I get y is equal to positive 1 when I divide both sides by negatives here. Now, where there's going to be trouble, if there's going to be trouble anywhere here, it's going to be dealing with the negatives. So just take it easy, take it slow. Make sure that as you calculate these, as you think it through, that you're paying very close attention to how the negatives are working here. Now I can take that back into either one of those original equations. It doesn't really matter at all. Maybe I'll take it back into equation 2. So y is equal to 1. So we'll make this x plus 2 times 1 is equal to 6. That's what equation 2 says. So 2 times 1 is 2. When I subtract 2 from both sides, I get x is equal to 4. So the point that I get as my solution is the point 4, 1. I got that x coordinate from going into equation 2, so I'm going to verify in 1. And so 3 times 4 minus 1 is equal to 11. Well, is 12 minus 1 11? Yes. Yeah. So clearly it is. Whoops. Whoa, here's where I put my answer. 4, 1 is my solution. Okay, here's another one that has a similar sort of issue here. Notice none of the coefficients are the same. So now I'm going to choose the easy way out of this one. Drop a line underneath here. I could get rid of the x's, okay? But to do that, I would need to find the lowest common multiple of 3 and 5, which is going to be 15. I'd have to multiply the first equation by 5, the second equation by 3. Now, I could do that. But let's look at the y here. This is 3, this is 6. The lowest common multiple between 3 and 6 is 6. All I have to do is multiply that first equation by 2. So 2 times 1. Now I have to be super careful about this. This is subtraction, this is subtraction. So when I put these together, I mean, I'm going to think about this as like negative 3. So this will be 2 times negative 3 minus, and I have a negative 6 here. In order to get rid of those, in order to get the y out of there, I have to subtract the second equation. Okay? Now I'll talk that through when I get there, and hopefully you'll see why this has to be subtraction here. 2 times 3 is 6, minus 5 is going to be 1x. 6 minus 5x. 2 times negative 3 is negative 6, minus negative 6. Minus negative 6 is like negative 6 plus 6. There's my 0. That's why they go away. If I do addition here, then I'm going to get negative 6 plus negative 6, and then the answer would be negative 12. Okay, you have to make sure that you are doing the correct operation here. If the variable that you're trying to get rid of has the same sign in both equations, then you're going to use subtraction. Okay, now 2 times 7 is 14, minus 8 is going to be 6. And so there we have it. X is equal to 6. Actually, that fell out of that question quite nicely. So now I'm going to take that back into, actually it doesn't, and in this case, it really makes no difference where I plug that in. I'm going to have to do a little bit of work. So let's just say we plug that back into equation 1. Okay, so I'm going to make the x coordinate here 6. So 3 times 6 minus 3 times y is equal to 7. Okay, what's going to be 18? So I'll write that out. 18 minus 3y is equal to 7. So I'm going to subtract. I'll subtract that 18 from both sides. So 7 minus 18 is going to be negative 11. So y is going to equal positive, whoops, can't see that, 11 thirds. Now that's an awkward number here. Kind of a weird number. So I'm just going to go back through and double check that I've gotten everything correct here. Okay, so 2 times 3 is 6, minus 5 is 1. Yep. 2 times negative 3 is negative 6, minus negative 6 is 0. Yep. 2 times 7 is 14, minus 8 is 6. Yep. And if I plug that in, 3 times 6 is 18. Yep. 7 minus 18 is my negative 11. Yep, that's what I get. So now I've got this point here, 6 comma 11 over 3. I used equation 1 to get the y coordinate, so now I'm going to verify in 2. So 5 times 6 minus 6 times y, which was 11 thirds, is equal to 8. Okay, so 5 times 6 is 30. All right, well 6 times 11 is going to be 66, divided by 3 is going to be 22. Oops. Now, is 30 minus 22, is that 8? Yes. So that did work. That was the correct solution. So my answer here is, in fact, the 0.6 comma 11 thirds. Okay, here we go with another question that's a little on the distasteful side, let's say. If you're comfortable with fractions, you can work with just the fractions in here, and that'll be fine. It'll work out beautifully. But you got to be comfortable with fractions. I suspect most of us are not, and most of us, when we take a look at that, are going to want to simplify this first. Okay? Now, at this point right here, I would be very tempted to want to just get rid of the y-coordinate by multiplying the second equation through by 2. Because if you do that, then you get negative a half plus a half, they cancel. However, okay, not everybody's going to be thrilled with doing some of the other fractional work here. So what we're going to do is we're going to change this system. Okay, and what I'm going to do is first of all, notice in my first equation, I've got denominators of 2 and 3 here. I'm going to multiply equation 1 by 6. Okay, 6 times 2 thirds is going to be 4. 6 times negative 1/2 is negative 3. 6 times 4 is 24. And there's my new equation 1. I'm going to multiply equation 2 by 4, because that's the least common denominator. Common multiply, I should say, the denominators. 4 times a half is going to be 2. 4 times a quarter is going to be just 1. That's easy. And then 4 times 5 halves is going to end up being 10. All right, now I've got a system, and actually maybe what I'll do is I'll rename these. Instead of calling this like equation 1 again, we'll maybe call this equation 3, call this equation 4. And what I will do, and I could do this one of a couple of different ways. I could easily get rid of x, I could easily get rid of y, it doesn't matter. I tell you what, most of the time I get rid of y, so let's get rid of x in this case. So what we'll do here is, in order to get those two coefficients the same, I simply need to multiply equation 4 by 2. So I'll make this 3 minus 2 times equation 4. So 4x minus 2 times 2x, those are going to cancel, and that's done on purpose. Here we go. Negative 3 minus 2. Well, it's going to be negative 5y. 24 minus 2 times 10. So 24 minus 20 is going to be 4. And when I divide, I get y is equal to negative 4/5. Whoops, sorry. Okay, well that's not a super pretty answer there. So let's just double check our math here. Well, 4 minus 2 times 2, so 4 times minus 4, yeah, 0. Negative 3 minus 2y, negative 5, yeah. 24 minus 2 times minus 20, 4. Okay, so that seems to work. Now, to get our x coordinate, I'm going to take that back into one of the original. I'll take it in equation 4 there. Plug this into equation 4. So 2x plus negative 4/5 is equal to 10. I am so lazy. I'm going to multiply everything through by 5 here just to get rid of that fraction. Okay, so 10x minus 4 is equal to 50. Now, I do this repeatedly, and I realize, and actually there's an opportunity here to talk about fractions that I'm skipping over here. There is an opportunity to work with fractions here and to improve your comfort level with that. However, my goal here is to make sure that you are really comfortable with what you can do with equations, and to make sure that you understand that you can multiply by that common denominator to get rid of that fraction. And I'm doing it so that you can see this repeatedly, that I have to multiply every term by that denominator. So like there is some method to my madness here. Now I'll bring that 4 over. So 10x is going to equal 54. And now I'll divide by 10. Okay, so 54 divided by 10, that's what we get here. And, I mean, those have both got a common factor of 2, so that's going to be 27 over 5. That's an awkward looking number here. So the point that I have here is 27 fifths comma negative 4 fifths. Well, that is not a particularly friendly looking little equation there. So I used equation 4 to get that coordinate, so I'm going to verify it in 3. Whoops, sorry, I got to make sure you can see that. I'm going to verify in 3. So again, my point was 27 fifths comma negative 4 fifths. So equation 3 was going to be 4 times 27 fifths minus 3 times negative 4 fifths equals 24. Is that true? Okay, well, 4 times 27 fifths. Well, that is going to be, what do we got here? It's going to be 4 times 7 is going to be 28. 108 plus, that's going to be 12 fifths. Does that equal 24? Well, let's just take a look here. 108 plus 12. Well, that works out nicely to 120 over 5. Does that equal 24? Well, yes, it does. And so, yeah, that's my solution. It's not a pretty solution, but it works. So it's pretty enough. There you go. All right. To solve this equation here, I'm still gonna make a change to it, but it's gonna be such a minor change. What I'm gonna do is I'm gonna bring that negative 12 over. So we're gonna get 3x plus 2y is equal to 2. 4x plus 5y is equal to 12. And I'm going to keep these as 1 and 2. I mean, I suppose I could have labeled these 1 and 2, brought the 12 over, and then created like a new system here, but that change is so minor. And as long as I'm careful with the negative sign here, I'm pretty confident that I'm okay here. Now, there is very little relationship between these coefficients here. I basically have to just choose a variable to get rid of. And I recognize that a lot of people are going to choose to get rid of the y here. So to do that, what we're going to do is I'm going to multiply 5 by equation 1. And because the coefficients here have the same sign, I'm going to subtract 2 times equation 2. So 5 times 3 is 15. 2 times 4 is 8. 15 minus 8 is 7. 10 minus 10 goes away, becomes 0. Okay, so the y variable is gone. That's exactly what I wanted. 5 times 2 is 10. 2 times 12 is 24. So 10 minus 24 is going to be negative 14. And a quick division there gets me that x is negative 2. All right, good. Now, I can use either one of those equations to get the y coordinate. I'll just say I'll use equation 1. So 3 times negative 2 plus 2 times y is equal to 2. 3 times negative 2 is negative 6 plus 2y equals 2. I'll bring the 6 over, so 2y is equal to 8. Y is equal to 4. So now I've got this point, negative 2 comma 4, that I believe is the solution. I used equation 1 to get that y coordinate, so I'm going to verify in 2. So 4 times negative 2 plus 5 times 4, does that equal 12? Well, 4 times negative 2 is negative 8. 5 times 4 is 20. Does negative 8 plus 20 equal 12? Yes, it does. And so my solution is negative 2 comma 4. All right. Now we're going to take a look at some word problems, and you're going to notice that solving word problems here is essentially the same as it was when we were using substitution. It's just that we're going to choose a different method of solving once we get to the system. But the issue here is, again, always about creating the system. Remember that typically you're going to have to identify your variables, and the variables come from what you're being asked for. And then usually, sentences become equations. So, a community group purchased 72 cedar tree and spruce tree seedlings. Okay, so we got, this is a total. 72 is a total. 72 cedar tree and spruce tree seedlings to plant for an Earth Day project. Okay, good. The number of cedar trees was twice the number of spruce trees. How many type of each tree did the tree seedling did the group purchase? Okay. So we're going to have to identify variables here. We're going to let x equal the number of, let's say, cedar, and y be the number of spruce. And again, I could have chosen variables c and s, and that might have made more sense. But I think, again, a lot of us like to use x and y just because we're really comfortable with that. Now, we're given a total here. 72 is the total of those two. So we know that x plus y is going to equal 72. Then we're told, and look at this next this sentence here, the number of cedar trees was twice the number of spruce trees. The number of cedar trees was twice. Now, was is going to take the place of an equal sign in that particular sentence there. So the number of cedar trees, x, was twice the number of spruce trees. Oops. So there's my second equation. Now, this is set up beautifully for a substitution. Beautifully. X equals 2y. I can just substitute that right in. I could make my point 2y comma y. However, that's not the point of this particular exercise. So what we're going to do here is I'm going to change this system. This is going to be equation 1. This is going to be equation 2. I'm going to change this system very slightly to make equation 1 x plus y equals 72. I'm not going to do anything to that one. But I'm going to bring the 2y over here to get x minus 2y is equal to 0. And there's equation 2. Okay, so now I'm going to use elimination to solve the system, and I am going to eliminate the x variable because it's set up wonderfully for that. So to do that, I will take equation 1 and I will subtract equation 2 from it. So x minus x disappears. Now be really careful here. Y minus negative 2y is going to be 3y. 72 minus 2 is going to be, 72 minus 0 is what I should have said. 72 minus 0, equation 2, is 72. And so now we know that y is equal to, well, if you divide 72 by 3, oh shoot, that should come to me right off the top, 24. 24. And then if y is equal to 24, okay, well actually we got a really nice way of figuring that out. If y is equal to 24, x has to be 48. Okay? Just because of this equation right here, x is twice that number. So therefore, I've got this point now, 48, comma, 24. Now I used equation 2 to get that, so I'm going to verify in equation 1. So I'm just going to verify in 1 that is 48 plus 24, is that in fact 72? Yeah, but yes it is. And so therefore we can say they bought, what was x? X was 48. So 48 48 cedars and 24 spruce. Spruces? Spruce. I teach math, not English. You can figure that out. Okay, another word problem here. Nuri invested $2,000, part at an annual interest rate of 8%, and the rest at an annual interest rate of 10%. After 1 year, the total interest, okay, here we go, here's a total, was $190. How much money did Nuri invest at each rate? So that's what we're looking for. So we're going to let's say x equal the amount at, what was it? Let's say, well, the first one was 8%. And we'll let y equal the amount at 10%. Now, I do have a couple totals here. One is obvious. The total amount of interest was 190. Okay, so here's an equation here, 190. So the amount of interest that I got out of this first one is not x. X is the amount of money. If you want the interest, you got to multiply that by that percentage here. So it's going to be 0.08 times x plus 0.1 or 10% of y. That's going to equal 190. Now, I'm not particularly thrilled with the decimals in there. I'm not really overly worried about it, but I'm not thrilled with that. But we'll get to that in just a second. there is another total that's given to us in here. It's for some people it's not obvious, but it is in some ways, really, it should be the more obvious one. Neri invested $2,000. $2,000 is the total. Okay? So x plus y is equal to 2,000. Now, I am going to take this system and I'm going to solve it. Now, I can do this one of two ways here. I can leave the decimals in there and simply work with the decimals. Or what I could do is I could eliminate the decimals. And that's actually not all that hard to do, because we can simply multiply by, for example, 100 here and just move the decimal places over. Now, it is my bet that most people are going to be happier if we do that. So let's just do this. Let's just change this system here. And all I'm going to do is move the decimal place over for every coefficient here in equation 1. So that's going to make this 8x plus 10y. But I got to remember to do it to both sides of the equation. That's going to be 19000. 19,000, because I have to multiply everything by 100 here. This is my new equation 1. And my equation 2 is simply going to be x plus y is equal to 2,000. Now, I hope you see that it's going to be fairly easy to get rid of either one of the variables at this point. Let's get rid of y. I think most people like to get rid of y. Let's do that. So we're going to take equation 1 and we're going to subtract 10 times equation 2. So 8 minus 10 times 1 is just going to be 8 minus 10. So negative 2x is equal to, now remember 10 minus 10, I mean that's going to go to 0. And I'm going to get 19,000 minus 10 times 2,000. And I'm going to get negative 1,000 right there. And divide by that negative 2, I'll get x is equal to 500. Okay, well that worked out really, really well. And actually, this is a fairly easy number for me to work with. I'm going to just jump back into equation 2. And equation 2 is going to get me that y is going to equal, if x is 500, y has to be equal to 1,500. So there's my point. So I've got this point here, 500, comma 1,500. Now I got that 1,500 from using equation 2. Okay, or equation 2, I use this one right here. I'm going to use equation 1 to verify. So I'm going to verify in 1. So that means 8 times 500 plus 10 times 1,500. Does that equal 19,000? Well, let's check it out here. Now, 8 times 500 is going to be 4,000. 10 times 1,500 is going to be 15,000. Does that equal 19,000? Yes, it does. So, therefore, Nuri invested $500 at 8%. Well, can you see that? Nope. And $1,500 at 10%. Good. Okay, here's a good question. It's kind of a geometric question. I like that. So Louise purchased a Métis flag whose length was 90 centimeters longer than its width. The perimeter of the flag was 540 centimeters. What are the dimensions of the flag? Okay, well, you know what? In a case like this, I was going to say it might help to draw this one out here. But actually, because of what I know about this question and how I know they want you to answer this, it might be easier just to, again, identify our variables. Let's let x equal the, what? Let's make it the width. And we'll let y equal the length. Okay. Now, we know right here, it says Louise purchased a Métis flag whose length was 90 centimeters longer than its width. So think about what that's saying. The length, y, was 90 centimeters longer than its width. That's the equation. The perimeter of the flag was 540. Okay, well, perimeter is going to be 2x's plus 2y's, and that's going to equal 540. Okay, so here's equation 1, here's equation 2. Now, I'm going to make some big changes. Well, sorry, that's maybe overstating it a little bit. I'm not going to make big changes, but I'm going to make a couple changes to the system to make it a little bit easier for me to work with. Okay, first of all, I'm going to bring the x over. So I'm going to create a new equation, equation 3, and I'm just going to bring the x over, make it negative x plus y is equal to 90. And then I'm going to create equation 4 by taking my perimeter equation here and dividing everything by 2. So x plus y is going to equal, okay, what's 540 divided by 2? Okay, well, I mean, the easiest way to do that is 54 divided by 2 is 27, so this is going to be 270. Now I've got a system of equations. It's set up nicely for me to solve. Away I go. I am going to take equation 3 and I'm simply going to add equation 4 that is going to eliminate the x's for me. And then y plus y is going to equal 2y. 90 plus 270 is going to be 360. And by quick division, I'll see that y is equal to 180. Okay? Now, take a quick look at this. If y is equal to 180, by using equation 1 here, if y is equal to 180, I know, okay, that x, sorry, I gotta look at that again here, that x has to be 90. So I've got this point now, 90 comma 180. I used equation 1 to get it, so I'm going to verify in 2. And it doesn't, I mean, as long as I've done that calculation from, like to change, when I change this one to this one here from equation 2 to 4, as long as I did that correctly, I could use equation 4. But we can do this in equation 2 here. 2 times 90 plus 2 times 180, is that 540? Well, 2 times 90 is 180. 2 times 180 is 360. Does 180 plus 540 equal, sorry, shoot, I said that wrong. Does 180 plus 360 equal 540? Yeah, actually, yes, it does. So therefore, the flag is 90 centimeters wide and 180 centimeters long. There you go. All right, for this question right here, okay, it's a mixture problem. It says an alloy is a mixture of metals, okay. An artist was commissioned to make a 100-gram bracelet. Okay, this is a total with 50% silver. Okay, now he has a 60% silver alloy and a 35% silver alloy. So now the question, and it's missing here, is the question really is, oops, how much of each should he use? Okay, how much of each should he use here? So we're going to let X be the amount of, let's say, the 60% alloy, and we'll let Y be the amount of the 35% alloy. All right, now there are a couple of totals here. One is an obvious one. The other one is not quite so obvious. First of all, we know that the total mass of the bracelet is supposed to be 100 grams. Okay, so X plus Y should be 100. Okay, that's the total mass of the metal that's going in. This is the total mass of the bracelet. The other one that's not quite as obvious, but it's still there, is that the bracelet is supposed to be 50% silver. Now, it's not exactly written here, but what this means is if it's a 100-gram bracelet and 50% silver, that means we've got 50 grams of silver. So the question is really about the amount of silver in here. Okay, so, well, how much silver are we getting from that first one? Well, we're going to get 0.6x. 60% of however much of that first one we plug in there. And then this next one's going to be 0.35 Y. That's the amount of silver that we're getting from that second one. And altogether, that should equal 50 grams of silver. And here's equation 1, here's equation 2. Just like with a previous question, I've got these decimals in here. I would kind of like to change my system a little bit. Now, I'm not going to rename them because my change is going to be pretty minor. I'm going to multiply the second equation through, like I did before, by 100 to move the decimal place 2 over. So my second equation here is going to be 60x plus 35y is going to equal 5,000. Okay, here's my system. Now I'm going to have to choose a variable to get rid of. Let's get rid of y. So what we'll do is here we'll take 35 times equation 1 and we'll subtract equation 2 from that. Okay, so 35 minus 60, okay, when we do that is going to be negative 25x. 35 minus 35, that goes away. That's exactly what I wanted. 35 times 100, okay, minus 5,000. That's going to equal negative, that's right. I got 0 happy there. Shoot. Is that clear? Nope, that's not 100% clear. Okay, I didn't want to write that. Actually, I'm going to erase that and start again. Negative 1,500. And when I divide that by negative 25, I get that x is equal to 60. Okay? X is equal to 60. Now, I know because of that first equation, because of number 1, that means y has to equal 40. And so now I've got this point, okay, I've got this point here, 60 comma 40. I got that second variable from equation 1, so I'm going to verify in 2. So I'm going to take, it'll be, well, I'll use the second version here. I'll use this big one here. So 60 times 60 plus 35 times 40, does that in fact equal 5,000? Well, 60 times 60, that's easy. That's going to be 3,600. Okay. 35 times 40 is going to equal 1,400. Does that equal 5,000? Yes, it does. And so he will need, what did we say? 60 grams of the 60% alloy and 40 grams of the 35% alloy. Whoops, sorry. And remember, just as we're finishing up here, remember that you need those pieces when you're doing these word problems here. Let me zoom out here. I need you to identify the variables. I need to know what your variables mean. I need to see a system. From there, I want to see you solve it. Now, usually with word problems, it doesn't really matter how you solve it, but we're usually expecting an algebraic solution. And then I need to see you interpret your answer. I need to know that you know how that math relates back to your choice of variables, relates back to the problem. Okay? There you go.